Hi guys, Joe Million from Hartwig here with a quick around the horn on AOT Mill. AOT Mill it stands for Advanced One Touch Integrated Graphics Function, and it's a software that's been around on the Okuma mills for some time, but it's becoming standard on some of the Genos line from here forward. It's available as an add-on option to existing machine tools out in the field. One of the things that IGF mill or AOT mill is really great for is that quick down and dirty programming that you might need to do whenever you're working on the shop floor. It might be really handy for the guy on the floor to maybe use for cutting some vice jaws or something real quickly, or handling some process that maybe somebody up in the programming department didn't have the foresight to handle. Another good use case for it would be for shops that don't have the overhead or don't have quite the volume to move themselves into CAM or CAD CAM programming or invest in a fully featured CAM system. What AOT is not great for, it's not great at highly complex work or work involving surfaces. If you have a lot of complex curves or surfaces, I don't recommend AOT for you. You're going to be struggling and finding yourself frustrated. That being said, let's get to going around the horn here. When you're running a machine in AOT, you might see this window whenever you first walk up to it. I've got this machine running in AOT mode right now, so we can run this machine without ever having to edit or change any of the code. For machines that have AOT, whenever we come over here to the program button and we click on this button here, we will have our NC program data, which we're used to seeing, but we'll also have our IGF data here. And most of our IGF data usually comes out of the folder AOT here. If I look here, I've got a few programs I've programmed already. I'm going to go ahead and create a new one. I'm going to call this AOT, create IGF data. I'm going to call this AOT-mill. We want to be caps lock on AOT-mill. And then I'm going to make this 2 because I've already done this exact file before. If I hit enter here and then OK, now I've got my AOT mill 2 that we'll be machining on. One of the first things it asks us is what our blank material is made out of. I could change this type of material here by entering a number. I'm just machining electrons inside of a simulator here, so my feeds and speeds aren't really critical to me. But very often you might find that 5150 aluminum has different cutting speeds than maybe a 400 series stainless. It does pick out feeds and speeds from a chart automatically, and that chart can be configured. And if you don't like the automatic feeds and speeds, you can, of course, override them. The next thing that it's going to ask for is which origin I want to use. I'm just going to be using work offset 1 for all of this. And then after that, it's going to ask us some questions about our part shape. So I have about an extra 100 thousandths hanging over in each direction. And outside of that, it's just a 6x2 block with the origin in the top left corner. Once I've determined my shape, I can go right into adding features. The first feature that I'd like to add here is, let me show you my part. I'm 6 inches long, 2 inches thick. I've got a pocket that's 1.5 inches wide by 3 inches long. The print's a little hard to see here. That's about a 1/2 inch deep with 3/4 radius pockets, and I've got a 1/2 inch radius on this one corner of the part here. So whenever I go to machine a feature, I want to feature add. Click OK here for offset 1. We'll do a contour. I can rename my contour at this point if I'd like. My outside works for me as a contour name. My cut depth will be how deep this particular contour is going. It's going a 1/2 inch deep. I'm only wanting to rough this particular contour. I'll go into adding a rough and a finish operation later, but it's important to note we can rough and finish, or rough, semi-finish, and finish with each operation. Whenever I go into my tool diameter, I can tell it what tool diameter I want. I don't have a 5-inch end mill. I've got a 1/2-inch end mill, might be a little more appropriate. And this stock removal box is my width of cut. So with this particular cutter, whenever I'm machining electrons inside of a simulator, I think 1/4 of an inch step over will do just fine. The next field that it's asking me for is to perform an auto decision on the tool. So when I'm machining whenever I'm inside IGF and I click this tool auto decision button, it's going to look at the tools that are installed on the machine in the magazine and try to determine which tool might be appropriate. There happens to be a 1/2-inch end mill in there already. So whenever I click that, it brings up an end mill. It's tool number 101. I didn't even have to worry about that. It pulled in my spindle speeds. It pulled in my feeds and speeds for me from the table chart automatically, and I don't even have to really spend too much time with that either. Now it's asking me for the shape that I want to define. My shape is going to be arbitrary here whenever we're doing an outside contour. There's not many other options available. And once I click that, it'll ask for my start point. So I can give it a start point of, my start point will be 0, 0, and 0. My offset direction would be left. My relief amount, I like to type space and hit enter to clear both of those fields. You could leave those fields there if you needed to jump over a clamp or something like that, and we'll leave that in condition okay. The next thing we'll do is we'll pay attention to these little cursor logos over here on the lower right-hand side of the screen. They correspond with these different arrows in the different directions that you might want to draw from our start point. So from here, I want to move to X of 6. So I'm going to type 6 to select that direction. Then I'm going to go to an X of 6 in that direction and enter. The next position that I want to go to draw this shape would be down in Y. So if I hit 2, I can move down in Y, and I'm moving to a Y of -2 inches. My drawing that I had a contour on that, or had a radius on the one corner. I can add a radius chamfer if I type the equal key here. It'll bring me up to a dialog where it asks for the radius. I can go ahead and add that. Notice that it doesn't draw it just yet, but it will draw it whenever I complete the line back to X0 here. Now I've got both that radius here and my line continuing around to X0. And then I want to go ahead and I want to finish this shape up to a Y of 0 as well. So that gives me my basic shape on this contour that it's going to try to machine. And now I can click the next approach and escape positions. For this particular method, it gave me an approach and escape position that I think is okay. It's going to try to come in on this corner, and it's going to try to come out on this corner. And then it's going to do that with the perpendicular line method. That is perfectly fine for what we're trying to do right here. If I hit end, now I've got my shape there. I can hit end here, and I can go to machining test. And if I hit cycle start here, it'll do a lap around the box. Now, I see something there that I might want to change. So let me go back and change that real quick. So if I quit here on this box here where it describes my cutting speed or my list of tools as they're going to run, I might change my cut depth to be 0.75 because I only want it to make one pass around the outside of the part instead of 2. I hit end. Now I go back to my machining test. And I cycle start. Now I've only got that one pass in depth around the part. I do want to add another feature here. We want to put that pocket in there, and then I have one more little bonus feature I'm going to try to add to this part. So if I want to add another feature from here, I go to machining feature. I'll want to make sure I move down to a fresh line here, and then I can go feature add. My origin number will be 1, and my clearance plane will still be that 200 thousandths that I used in the first one. That's okay. I want to select a pocket this time, which is option number 3 there. I can call this pocket 1. That works for me. My cut depth, I'm going to go with 0.375 for this particular tool. I'm going to This time, instead of just rough it, I'm going to use the rough and finish. So I'm going to use number 3 here to give me the rough and finish. And then that'll give me a rough tool, or I can determine now what my rough tool diameter will be. 1/2 inch will be good enough for my rough tool diameter. And I want to use 1/4 inch for my finish tool diameter. I think that'll give me a better result on the inside of that pocket. I'm not going to bother to pre-drill any holes, but I am going to do my tool auto decision. And so whenever I hit F4, it'll bring up these 2 tools, and it picked for me a tool that I had on tool 101 that's already in use in this program. And then for my second tool to finish that pocket, it picked tool number 125, which was a 1/4 inch end mill that was already in it. It brought in, again, my feeds and speeds from the table that was predefined. From here, I didn't define my shape. Oh, shape designate. Now we'll define our shape. I'm just going to say this is a simple square. I'll put my start point in corner 4 here because I think that makes it the easiest for my particular pocket to be defined. My reference point there will be x of 1/4 inch, y negative 0.25 inches. And then my cut height will be 0 from there. I'm going to go ahead and hit space and then enter to get rid of that clearance amount. My side length dx will be 3 inches. My side length dy will be 1.5 inches in this case. My rotate angle will be 0. And my chamfering, I'm going to go ahead and give it a radius chamfer with a number 2. And I'm going to define that radius to be 0.375 inches. There I have my pocket. Now I can go to generate my approach and escape positions. So my approach motion here, I'm going to say for my approach motion that maybe I want to do a helical entry instead of a perpendicular entry here. So let's see if it'll let me change that entry motion to a arc. Oop. Approach escape. Next, cut motion. My cut motion is going to be helical. So number 2. My cut position, I'm going to make optional as well because I want to move if we see this red circle here, I want to move that entry point to maybe be an x of 2 and a y of negative 1.0. So that entry motion is not trying to being defined on the edge of that arc. Outside of that, I think the rest of my entry arc will work. Okay. And then I could hit end here, or we could come in and we could play around with the other shapes that we needed to play with for their entry motions as well. But it's only that roughing tool that I want to really helix in anyway. End. So now if I come in here, I hit end here and I do my machining test. Cycle start. I've got my part there as I've defined it so far. I want to make a couple more changes I see to this because I don't think maybe our finishing tool needs to machine that floor. So one of the things that I can do now that I've seen that, I open this up. I can come in here. If I go feature condition switch, go to my second page, I can turn my face wall separation on, and then I can turn my face cut so I'm not cutting the floor of that pocket with my finishing tool again, and I'm only going to be finishing on the wall. Then hit OK here, or end here, and that should, whenever I go to machining test this, now we shouldn't see that finishing tool. Yep, it just goes around the outside of the pocket. It doesn't go to finish the floor of the pocket anymore. We quit here. I have one more quick feature to show you on this particular quick around the horn here. I would like to add a machining feature that is less a feature and more an existing program. So at some point in time, you're going to have data that you want to get either either, you know, this software wasn't capable of handling the shape, or you're going to have something that's too complex and you need a subprogram to handle or something like that. And this particular function I'm getting ready to demonstrate will do that. If I go, instead of selecting contour, groove, or pocket here, if I go to machining feature 2 and I go to this NC program tab, it'll allow me to add. I'll want to pull a tool out. I'm going to pick an engraving tool. Got my spindle RPM. I'm going to go ahead and slow down my spindle to 5,000 RPM just because my first cutting position for this particular feature is going to be an X of, I'm going to say 0.25 should work for us, and a Y of -1.5 I imagine would work pretty well. Our first cutting position in Z will make 0. Our coolant on off, we could control all of that if we really wanted to, but that's not so much what we're looking for. I'm looking for this program edit button. And so whenever we're using this particular feature, it will bring our tool in for us and bring it to that start point we defined, and then it'll leave it up to us to define what to do from here. And I happen to have written an engraving program that's capable of engraving serial numbers on parts, and I'm going to try to run that program inside of that pocket we engraved. E and G. It will do a serial number, snum, and then I think I'm going to get a random number here. Just to prove that it's a random number generator, I'll go with 407. snum equals 407. I have to give this particular cycle a feed rate at 200 inches per minute and a depth. We'll make a -0.4. So we go 200 thousandths into our 375 thousandths deep pocket. That should be all the information I need to give this subprogram to make it engrave the number 407 in the bottom of that pocket. And then we'll hit feature complete here. And we can go to machining end here, and now we can go to machining test. Now it will complain that it can't draw everything here because this particular preview window does not have access to the code that's causing that subprogram to work, but it will work in reality on the machine. Hit OK here. We can still cycle start this, watch our program go around, and it would, or if we watched real quick, it showed where that start point came in, but then it quickly moved out of the way. Quit here. So when we want to go to run an IGF file, one of the options that we have is to run it as an IGF file. And if we want to do that, we can hit this end/machining button, and then I can hit this save in machining button as well. That automatically selected the part file. It brought the code for it, which I've up until this point not seen, into right here. And then it'll allow me to go straight into the animated simulation and run the part. So the machine's going to get a tool. It's coming down. It's running that cutter around the outside of the part. And this is happening in real life, by the way. The machine that this is on, or most of the machines that you would be programming with AOT wouldn't have CAS. This particular simulator does. So here is something this simulator thinks is a real machine going around the outside. And here is the graphical demonstration that you'd have inside of IGF or inside of a machine equipped with IGF to preview that. There I'm helicking into the pocket. It's machining the pocket for us. This pocket cycle can be edited and changed, and you can go from more of a spiral in, spiral out. There's a lot of customability there. Maybe I want to bump up my feeds and speeds a little bit because I don't want to waste so much of your time watching this run. Going to machine a second depth pass here. It'll finish around the outside. And now it'll go get our finishing tool that we were going to use for the pocket. Can make this bigger. Do the outside of the pocket. And I made a typo in my deal here. Whenever I'm doing one of these files, I can go straight in here. I forgot an equal sign in my PD equals 4. That was my programming mistake here. And I'm going to, since I'm at it, speed all of these speeds and feeds up too, so we don't waste so much time the second time around. Do that right here on the fly. It doesn't know what my speeds and feeds are for that. We're going to go end machining, save in machining. And now I can try to run that all again. Oops, I have the wrong tool command. Let's fix that real quick. Gotta be in manual mode. This does think it's a real machine. I'm gonna have to hit prepare start whenever I'm running in this particular cycle. Now I can hit start again. And if I go window change, or display change to animated simulation, we'll get this part drawn up here a little more cleanly. Machining that pocket. Helical down a little further here. Machine another pass on that pocket. Now it'll machine the outsides, or it'll semi-finish the inside of that pocket more or less, and now it'll come back with a finishing tool to finish the walls of this pocket. Again, this machine thinks it's a real machine running in real life at the moment. Now it's going to come in with the engraving tool, and it's going to engrave our number in that pocket. There's our 4, there's our 0, and there's our 7. Our engraving program is done. And that concludes our the entry part of our presentation. There is one more thing I want to point out here, that I don't always have to use this particular view or this particular option whenever I'm doing an IGF file. Another thing I could have done earlier whenever I ran into that mistake, or another thing I could have done from the beginning, would be to open this file, and rather than hit this in machining box, I could hit this program create, and I could make the file. I could give it a program name if I really want to. I don't need to. I'm just going to create and select that file. And now if I look at this window will look a little different. And this is probably what more people are used to seeing whenever they look at an Okuma mill with a P300 or later controller. But this will still all work the same way. But what this does now is, instead of whenever I hit edit, it bringing back up IGF for me to edit the edit file, I've got my quick edit button. And I could have come in here and just changed that one character that I was missing if I really wanted to. I'm going to save that file without saving, or I'm going to exit that without saving my file. File save, okay, no. And we're just going to run another quick test on this to make sure that it's still doing what we want it to do. There, it's going around the outside. But now here we're running from a more traditional program, more like we typically would if we were posting out of a CAM system. What's nice about this is that you can edit the code. You know, even the best of CAM systems occasionally have some little straggly code that you don't want, that you want to optimize away. IGF will be no different. in that regard. So if you're one of those people that want to highly optimize your code, outputting code like this may be a better option. If you're one of those people who's really timid and afraid of messing with the G code, you can generally run from IGF and never have to edit any of the code directly. Now we're going to come back and we're going to machine the outside of the pocket. Or the very outside pass of the internals of that pocket, more precisely maybe. And we'll come back with the engraver and engrave that for 07. All right. Again, my name is Joe Million. I'm with Hartwig, and I hope you enjoyed this presentation. Thank you.